This is section 4.1, transformations of graphs. So we're going to look at these on the calculator to see what's going on. So we have the parent function, which is like the original, the blueprint. Let's flip over to our calculator. So I do need to graph. If you need to clear out equations, just hit menu and you're on actions, delete all, and it will delete all the equations you have in there. Again, if you need to readjust your window, do menu, window zoom, and go to zoom standard, and it takes you back to a standard window. All right, so we need to put an equation in, so we're going to hit tab, and I'm going to put in x squared and hit enter. So that's what x squared looks like. Now they have two other equations there, so I'm going to put 2 in so we can compare the first and the second. So I have x plus 3 with a square on the outside. So what happened to the equation? The blue is the original, the red is the transformation. It moved it left 3 units. Okay, so let's go up here. And we're going to change that to a -4. So if we do -4 on the inside, pull these labels over. You can see it moved to the right 4 units. So let's go over to our notes. And you can put your graphs in here if you need to. So +3 moved it left 3 units. And -4 moved it right 4 units. And this is the terminology that they use in MyMathLab. All right, so if you're inside the function, you are going to have a left-right movement. Or you could put shift. And it's going to be the opposite direction of the sign. You say if it's negative, you're going to move right. Or if it's positive, or addition, you're going to move left. And remember, you can pause this if you need to stop and finish your notes. All right, so let's look at these. This time, the numbers are outside the parentheses. Tab, arrow up, Control, Delete. And I do want to leave that first one in the F1. That's our original, our parent function. So let's put a second one in. So let's do x squared plus 5. And you can see what happened there. We can actually put 3 in if we want. Let's do x squared minus 4. -4 is on the outside. So these labels. So that's the original. This is up here. So a -4 shifted it down 4 units, and a +5 shifted it up 5 units. So this one went up 5 units. And this one went down 4 units. So this is what we call outside the function because it's not in any type of grouping symbols. So outside, we have a up-down movement or shift. All right, so if it's positive, it goes up. If it's negative or minus, positive also means plus, it goes down. Let's look at some more transformations. I still want to keep the parent function, the x squared. So tab, arrow up, control delete, hit enter, tab, arrow up, control delete. I still have the x squared in there. So this one, I want a negative x squared, and let's see what that does. Move these so the labels make more sense. All right, so x squared opens up, negative x squared opens down. So you could say it flips it down. It's called an x-axis reflection. Right. So if you need to make more notes, you have room down here where it says rule. So let's put in a 6x squared. So tab, arrow up. You can control delete and start over. So if I put a 6 in, okay, the blue is the original, the red is the one with the 6 out front. So it made it skinnier, and that is a horizontal stretch. It's a vertical stretch, I'm sorry. All right, so now we have one with a 3/4 x squared. So what we are is we're looking at numbers that are less than 1/3 doesn't give us a good picture, so I'm going to take it down to 1/4. So what happens is it makes it wider. So let's go up. Let's just make this smaller than 1/4. 3.1. It's 1/10. See how it's getting wider? So the smaller the number is out front that's less than 1, it's getting wider. That is a horizontal compression. So anything between 0 and 1 or 0 and -1 gives us a horizontal compression. And then you can write whatever you want for the rule. That's kind of open there. Again, those are just notes for you to keep track of whatever makes sense to you. All right, so now we're going to work with these. So we have the original function is y is equal to x squared. So our original is x squared. Write a function that has the following transformations. It's shifted 2 units to the left and down 6 units. So 2 units left. Left and right is inside. So if you go left, that's going to be plus 2 squared. And down 6 units, up downs on the outside. So that's minus 6. I'm going to pull the calculator up. Leave that out. And then I'm going to put in what we had. X, let me look at that real quick. We had plus 2 squared minus 6. All right, so let's go back to the notes. 2 to the left and 6 down. So we went 2 to the left and 6 down. So left and down is what we did. Okay, so that is the equation of the line. So you can use the graph to check it and make sure we went left 2 and down 6. All right, this one, the original, is still x squared. We want to go up 5 units. That's the one that disappears. Up 5 units. We have a reflection over the x-axis and is stretched by a factor of 4. Okay, so y equals up 5 would be plus 5. Reflected over the x-axis is negative and stretched by a factor of 4. So negative 4x squared plus 5. Let's flip over to the calculator. Tab, arrow up, control delete. So negative 4x squared plus 5. Let me double check that real quick. All right, so it shifted it up 5 units. It stretched it, which made it skinnier by a factor of 4. And the negative then flipped it down. So again, we can use the calculator to check and make sure we have, sorry about that, the right equation. All right, so now we have some other functions and we want to see if the same transformations apply. So the original we have here is the absolute value of x. So let's flip over to the calculator. So I'm going to hit Menu, Actions, and delete all since I'm starting over with a new function. Tab, and let me show you where the absolute value is. It's this thing that looks like a book. And you're going to have to find the right one. I'm looking for it. Hold on a second. Here it is. Okay, it's this one right here. And then as soon as you find it, you hit enter. And we're going to type in an X and then hit enter. So absolute value looks like a V and it's centered right there at the origin. All these functions are centered right here at the origin. All right, so let's look at our notes. We have plus 3 on the inside, minus 4 on the outside. So you can think about, what do you think it should do? If it's a plus 3 on the inside, that's a left-right movement. It's the opposite direction. So that means I should go left 3 units. And inside means it's inside grouping symbol. This is inside the absolute value bars. This is outside, that's an up-down movement. It's negative or minus, so it's going to be down 4 units. All right, so we're going to hit tab, and we want the absolute value bar. So when you hit the little book button, it's going to default to what you used last, which is nice. And then you hit enter. That's the only thing we're going to use in this area. So x plus 3, arrow to the right to get outside the bar and put in minus 4. And we said it should go left 3 and down 4. So we went left 3, down 4. So that is the same type of transformation we're seeing with the x squared. All right, now we're going to do the square root of x. So menu, actions, and we want to delete all. Tab, and the square root is right above the x squared. So it's control x squared and x. That's the parent function, the original. I call it a sad curve. It is starting right here at the origin. Kind of falls to the right a little bit. So let's look at this. And then again, you can sketch these in if you want. If you need a little bit of a reference. All right, so we have this 5. That 5 is on the outside. So that means we have an up-down movement, and it's plus 5, so we should go up 5 units. Out front, we have a negative, so that should give us an x-axis reflection. What would that look like? Let's see. We take this and we go up 5, and then flip it down. That is what it should look like. Okay, but if you're unsure, let's see what's going on in our calculator. So we want to put the negative first, and then the square root of x, arrow to the right to get out from underneath, and that's what you get. So let's go back up to that one. I want to show you something. All right, if you forget to come out, if you end up underneath the square root, that moves it to the left or right. So it's really important that if it's outside, that you arrow to the right and then put in the rest of it. Okay, big difference there. And on your homework, you'll have different ones. So the same transformations are going to apply, but you may have some different functions. Determine the graph of the equation. So first thing we need to do is determine what is the parent function, what is the original. Okay. So given the shape of this one, the original is x squared. So if it was x squared, it would be something like this. So if we take this, the vertex, it's moved here, that's at 9. So that means we went up 9 units. And then after we went up 9, it flipped it down. We had an x-axis reflection. So we had two transformations going on. We went up 9 units and we had an x-axis reflection. So the equation is y equals x-axis is negative x squared, and up 9 units is plus 9 on the outside. Okay, so menu, we're starting over, so let's delete all. And I'm just going to put in what I have. I think we said plus 9. All right, but our window doesn't look like theirs. Let's see what that window is. -4 to 4, -2 to 12. So this is where when we first learned how to manually set your windows. So this looks better. It's more along what we have on the screen. So you can double check your equation. All right, so this one is actually in a 12 by 12 on the window. So let's go ahead, let's delete all. And you can change the window after you graph. All right, so the general shape here is a V shape. Okay, so the original is the absolute value of x, has a V shape. So originally it's centered right here at the origin. So we went this way So we went right. That's 8, 10, 12. So we went right 10 units. And then we went down 8. Right 10, down 8. I'm going to erase this. So to the right or left, that's inside. We went right. So it's going to be minus 10. And we went down, up, down's outside, minus 8. So let's check this on the calculator to see if we have it right. Tab, open the book. All right, and that looks like what we had. We went to the right 10 and down 8. So you can use the calculator to check your work. All right, so now we're going to look at symmetry. There are ways to find symmetry algebraically. It's kind of a pain. I'm just going to show you visually how you can determine symmetry. So basically, if it's symmetric to the x-axis, if you fold it on the x, a sheet of paper, you just fold it that way, then you will have a mirror image. The two pieces of the graph will match up. If it's y-axis symmetry, if you fold on the y-axis, the graph is going to match up on both sides like a mirror image. And origin's a little bit different, but I'm going to show you that. So this is 8x squared minus 9. You can graph it if you want, but I'm just going to show you what it's going to look like. It doesn't have to be exact. All right, so if I fold it on the x-axis, this is the mirror image I get, if I can draw better. Okay, that doesn't lie on top of itself. All right, let's look at, let me change my color real quick. It's going to be helpful. I'll look at y-axis symmetry. If I fold it on the y-axis, it's going to fold on top of itself. It's a mirror image. So this is an example of y-axis symmetry. All right, let's look at this one. X cubed minus 9x. If you want to go back to standard window, you can. But it's always so good to be in a window that's, same amount on top and bottom and left and right. So if it looks like there's some type of symmetry, but if I fold it on the x-axis, let me show you what happens. If I fold it on the x-axis, there it is. It looks like this. Okay, so that's no x-axis symmetry. Fold it on the y-axis. It's going to look the same. Yep. All right, so it's not folding on itself on the x or the y. But again, it looks like it's symmetric. So what this is, and let me do this in red so we get a really good picture. That's red. All right. So if I fold on, let's just fold on the X. And I'm just going to do this one side on the right. And then I fold on the Y. It matches up. It's a double fold. So it looks like there's some type of symmetry. We can't determine what it is. This is symmetry about the origin. All right, 13 over X. Again, you can graph these in your calculator. That's what that one looks like. It looks like there's some type of symmetry, but if I fold it on the X or I fold it on the Y, it looks the same. But if I double fold it, I fold it on the X and then fold the dotted ones over, and then it's going to line up. So this is symmetry about the origin. All right, this one here, technically you can put it in your calculator. You have to do two pieces. X squared plus Y squared gives you a circle. And let's pretend it's round. But this would be X-axis, Y-axis, and symmetry about the origin. So it folds and matches up on the X, it matches on the Y, and if we do a double fold, it also matches up. We don't have any just Y. I'm just going to sketch one in here. I mean, just X. This would be an example of, oops, of X-axis. If you fold it on the X-axis, it's going to match up. All right, determine if it's even, odd, or neither. Even means it's symmetric about the y-axis. Odd means it's symmetric about the origin. I have a little trouble finding my pen sometimes on here. All right, so if you graph this one, it's going to look like this. I guess this is what to draw lines in. So that one is symmetric about the y-axis. If we fold it on the y, it'll match up. That means it is even. Let's look at this next one. Oh, that's an odd one. Let's put that one in. All right. So square root of x to the 8th. Let me look at that again. Plus 10. All right. Looks kind of weird. Almost flat. It's not really totally flat. But looking at that, that symmetry is going to be y-axis again. So that means it is even. And this one's like 13 over x, 9 over x. They all have the same shape. You really wouldn't be able to tell them apart. So this one is a double fold. It is symmetry about the origin. So it is odd. All right. Just a few more down here. I think I pulled these images off the internet. So this one is actually a sine. We don't do trig, but if you look at it, it looks like there's some type of symmetry. But if I fold, I'm just going to do the right side. If I fold on the X, it's going to look like that. It's not folding on itself. If I fold on the Y, it's also not going to match up. What about if I double fold? All right, so fold over the Y and then fold over the X. It will match up. So this is symmetry about the origin. So it is odd. All right, and there's another one of these. It's similar to this that appears on the homework. It looks a little bit different. I have a hard time drawing it. It's going to look like this. It's actually cosine. If you look at that, that's symmetric about the y-axis. So it would be even. So you may get one that looks like the original that we have in blue, but if it looks like the one in green, that's actually cosine, and that is symmetric about the y-axis, so it's even. So our circle, we said it was what? Y-axis, x-axis, origin. But it's not even or odd. Okay. It's not even or odd because it's not a function. That's a multiple choice one. It's not a function. If you remember from chapter 1, it fails the vertical line test. It is not a function. This one has symmetry about the x-axis, but it's not even or odd because it is not a function. Again, it would fail the vertical line test. And that is it for section 4.1.